Hi, in this video, we're going to talk about if the future value of a series of even cash flows, and we're gonna really uh, do an example as well as explain some concepts so that you have a very good understanding of what this concept means. Uh, so this video is about a series of cash flows that are the same time after time, right? So before we do an example, let's just define some terms. Let's define what annuity means. What does an annuity mean? Annuity means it's a finite set of level sequential cash flows. These are different cash flows that are sequential. What about ordinary annuity? Ordinary annuity simply means an annuity that has the first cash flow occurring one period from now. So this is indexed. This flow is indexed, or it occurs at time is equals to 1. Another definition that we have, or we have to understand before we go to the example, is annuity due. Annuity simply means an annuity that has the first cash flow occurring immediately. That is, the first cash flow occurs where it's indexed at time is equals to 0, right? One last definition before we go to our example: a perpetuity. A perpetuity simply means, or a perpetual annuity, in other words, is a set of never ending sequential cash flows with the first cash flow occurring one period from now. Basically, one period from now means at t is equals to 1. Now that we have these definitions out of the way, let's do an example. So equal cash flows. Now we're talking, there are uneven cash flows, but now we're talking about even, the same amount of cash flows, equal or even cash flows, or ordinary annuity. So what did we say about equal cash flows or ordinary annuity? It's a type of cash flow that has the first payment occurring at time is equals to 1. All right. So let's say that we have let's say that we have 5 say we have 5 separate deposits. So I'm just going to explain this with a timeline. A timeline is very important for visualizing this cash flows, but I'm just going to, lay down the ground here. So let's say we have 5 separate deposits of $1,000 occurring at equally spaced intervals of 1 year with the first payment occurring at time is equals to 1. So now let's underline some important concepts. What do we have? We have 5 separate deposits of 1,000 occurring at equally spaced intervals of 1 year, with the first payment occurring at t is equals to 1. So now let's put this on a timeline so that it's easy to understand. So we have this timeline, right? And we have 1 here, 2, 3, 4, and 5. So let's say that this is 0. So at time is equals to 0, this is what we call now, today. Let me just decrease the size of my pen so that it's easy to write. Today, or present time. Okay? And this is t is equal to 1, t is equal to 2, t is equal to 3, t is equal to 4, t is equal to 5. So basically this line is time. Now, let me do purple. So this is year 1. This is year 2, this gap. This is year 3. This gap is year 4. This gap is year 5, right? So what else? What other information do we have? We have that this ordinary annuity pays a 5% interest rate per year. So let's say that every year it pays 5% interest. interest. And now let's say the first payment, what did we say here? The first payment occurs at t is equal to 1. So that $1,000 payment occurs here at t is equals to 1. So let me again change this to black. So at t is equals to 1, here we have t is equals to 1, we have $1,000 payment, right? So let's just do this here. So at t is equals to 1, let me just do green. At t is equal to 1, we have $1,000 payment. And at t is equals to 2, we have another $1,000 payment. At t is equals to 3, we have another $1,000 payment. Again, at t is equals to 4, we have $1,000 payment. And at t is equals to 5, another $1,000 payment. All right. So the problem that we're trying to solve, let me just make this smaller so that I have space on the right. So what happens is that at time is equal to 0, now, today, at the present time, there is no cash flow. Cash flow starts at t is equal to 1. Maybe there is some kind of event that's not a cash flow event. Let's say at time is equal to 0, you won a lottery. And instead of taking the lump sum amount for that winning, you wanted to take, this cash flows at the end of each year. So this lottery that happened today, this present time, will pay you $1,000 at the end of each year, compounded annually with 5% interest rate. So now the question, what we have is the question, or what we're trying to do is to calculate, the problem is calculate the future value of this regularly occurring cash flows, which are called ordinary annuity, to calculate the future value of this ordinary annuity after the last deposit of $1,000, which occurs at t is equals to 5, which is this last deposit at t is equals to 5. So after depositing that $1,000 at the end of year 5, what will be the value of all these payments, compounded 5% annually? Now, if we remember, the future value at n is calculated as present value multiplied by 1 plus the stated annual interest rate divided by how many times the payment is compounded annually to the power of mn, total compounding, right? So in our case, this 5%, which is 0.05, 5%, which is this 5%, is compounded annually, which means it's only compounded one time per year. So m is 1, and m is 1 again here, n. So this will give us a formula, PV, or let's just say this is RS, the stated annual interest rate, which is also 0.05. So this is just 1 plus RS raised to n. And if m is 1, this RS, we can just call it an R. So PV 1 plus R raised to n. So this is the formula that we are going to use to calculate the future value at the end of each period. All right. So once we have this, let's do our calculations here. So $1,000, at the end of the fifth year will have been in the account, will have been in the account. So this is provided that you don't take this $1,000 out of the account. So if you let it sit, right? If you let it sit, you have to let it sit in the account. So this $1,000 that is being paid into the account from your lottery winning, if you let it sit, this $1,000 payment at t is equal to 1, how much will it be at the end of the fifth year? So let's follow this green line, right? And say, using this formula, PV1 plus Rn, let me just write this at the top so that we can easily see it. Future value is present value, 1 plus R raised to n. So this $1,000 present value is $1,000 times 1 plus our R is 0.05, and it's going to be this $1,000 would be sitting for 1, 2, 3, 4 years, so raised to 4, right? So that will be about 1,215,506,250. And now we have this $1,000 sitting in the account for 1, 2, 3 years, right? So this $1,000 is going to be compounded 5 times per year for 3 years, and this will give us 1,157.625. And this $1,000 will be at the end of the fifth year will have been compounded for 2 years, right? This $1,000 for year 5, for year 4 and year 5. So that's going to be $1,000 compounded at 5% interest for 2 years, and that would have been 1,102.50. This $1,000 that has been paid into your account from the lottery winning at time is equal to 4, or at the end of the fourth year, would have been in the account for only 1 year, right? Because it's being paid here, it's only going to stay this year, 1 year. So 1,000, 1 plus 0.05 raised to 1, and that is going to give us $1,050. And now this last $1,000 that's paid into your account from the lottery winning at the end of the fifth year will only be sitting in the account for 0 years. Like, interest will not be calculated because we are calculating the future value at the end of the fifth year. That $1,000 payment that happened at t is equal to 5 will have been in the account for 0 years, right? Or for the 0 period. So 1 plus 0.05 raised to 0, n is 0 for this payment. So it's just going to be $1,000. Now, if we add all these payments, we will receive 5,525 and 63 cents. So what this is this is the future value of this ordinary annuity after the last deposit of 1,000. So what happens is that you win a lottery in the present day. This lottery winning will pay you $1,000 at the end of each year into your account. The question was, how much it will be worth at the end of the fifth year, given that you don't take these $1,000 from your account, you let it sit there and it's compounded 5% annually. It will be worth $5,525.63 at the end of the fifth year. Okay, so now this is we're adding each future value for the 5 years here, but we have a formula for that as well. So the formula is the future value at the end of n period is simply a times 1 plus r raised to n minus 1 divided by r, where a is the annuity amount, which in our case is $1,000, right? And of course, R is the periodic in our case the annual, because it's only compounded annually, the periodic interest rate, all right? And FVN, or the future value N, is defined as the future value of the ordinary annuity at t is equals to n. In our case, at t is equal to 5. So using this formula, we can arrive at the same number by FVN, which is 5 in our case, and A, the annuity amount is $1,000, right? Multiplied by 1 plus our periodic interest rate is 5%. Our N is 5 minus 1 divided by 0.05. Now, if you do this, it will be $1,000 multiplied by this expression. This term will reduce to about 136, I think. So, and then you multiply that by 1,000, and it will give you around, that's going to be the same amount, 5,525 and 63 cents. You can do this for yourself and see if these two calculations, give the same amount. So now we're going to do a real life, a real world example so that we can see how this is applied, right? So let me just go ahead and import this problem. Let me go ahead and import this problem and see for yourself what we're being asked here. So here it says, suppose your company's defined contribution retirement plan allows you to invest up to 20,000 per year. So now your company, the company you work at, so what is a defined contribution retirement plan? I mean, it's like back in the days, the most common retirement plans were defined benefit retirement plans. Defined benefit retirement plans are usually almost exclusively in your retirement account. It's the employer that contributes the amount, basically. And the burden of letting you have a retirement money when you retire was almost exclusively on the shoulder of the employer. So from a defined benefit retirement plan these days, we have, we've we've before we used to have defined benefit retirement plans, but nowadays we have defined contribution retirement plans where the employee shoulders a significant amount of responsibility for their retirement account. So these employees contribute a defined amount. In this case, for example, it's capped at 20,000 per year, so that's the maximum amount allowed by this employer. And so this is what we call defined contributor retirement plans. And sometimes employers they will choose to match your contribution, so that your retirement account will grow better than if it was just you that's contributing to the retirement plan. So this has a maximum of 20,000 per year, and then you say, okay, maximum 20,000 per year. I'm just going to contribute 20,000 per year, right? And this fund, or this amount that you put into your retirement account will be invested by your employer into a stock index fund for the next 30 years. And this stock index fund will pay you a 9% interest rate on average per year. Okay. Now, assuming that this 9% is applied every year for 30 years, right? The question is, how much money will you have available at the end of 30 years, or when you plan to retire after 30 years? So let's see what we have here. So the annuity payment that the payment that you're going to be contributing at T1, T2, T3 up to T30 at the end of each year is 20,000. So that gives us A is equals to 20,000 euros. This is your ordinary annuity amount. And then the interest rate, the periodic interest rate, and that's the annual interest rate, and it's compounded only annually, one time per year, is 9% or 0.09. The number of years that we're interested in is 30 years. And the question is, what will the future value be at the end of 30 years, right? So the general formula we have here, FVN is equals to A times 1 plus R raised to N minus 1 over R, right? So for us, it's FV30 is equals to 20,000 multiplied by 1 plus 0.09 raised to 30 minus 1 divided by 0.09. And this will give us around 2,726,150.77 cents. So by the time you retire after 30 years, you will have about 2.7 million euros in your retirement account. So this is a very good example, and it will let you calculate how much money you'll have given these characteristics of the ordinary annuity. So this is something that you might face in the real world as well. So this is basically an ordinary annuity, or a series of cash flows that are even cash flows. Even means they are the same. It's 1,000, 1,000 at the end of every year. It's 20,000 at the end of every year. You're not varying the amount of money you're going to be putting into the account every year. So this is an even cash flow. And the next video, we're going to see an example where these ordinary annuities are uneven or different from year to year.